Okay, let's begin. Welcome everyone to the Codementor office hours, and we'll be talking about Android MVP architecture tonight. The format of the session is going to be a little bit of housekeeping first. I would again request everybody who is joining to please mute their mics and stop their videos, because the session is going to be recorded live and it will be published online publicly. And secondly, if at any point in the session you have any queries, please mention your query in the chat window, and we will take that up in the Q&A session at the end. And mm, uh, now a little brief intro about myself, and then after that I'll give you a brief intro of how the session is going to be like. So my name is Kshitij Agarwal. I am an associate architect with Callan Software. I'm also a speaker for GDG New Delhi, and I also mentor startups from time to time with their Android applications, and I mentor the teams. And my day-to-day activities are mostly close to basically I help developers in reaching the point where they are not just coders but they are developers. So that is what I'm striving for. I'm very actively trying to build up a community in Delhi NCR. So okay, again requesting everyone to please turn off your mics and stop their videos. Okay, now the format of the session is going to be like this. We are going to quickly run through a slide deck, and where we will see the comparison of MVP with MVC. And after that, I'll be giving you a walkthrough through a commit history of a project on GitHub, which is a small code lab on MVP, and we'll go through the commit history and see how to develop an MVP app step by step, what you need to do, from where to start, and what you need to do to as we move forward. So we won't actually be coding live, but we will be still able to see what changes we are going to make. So I'll be showing a diff of the code as we move along and going through the commit history. Okay. Okay, again, reminder, any questions, please put into the chat window. Okay, so Varun, you're not able to listen to me properly. Is that true for everybody else? You can respond through the chat. If that is a problem, I still request everyone to please turn off their videos. Now I'll be turning off my video, and I'll move on. I'll share my screen and start with the slide deck. Okay, I hope everyone can see this. Okay, so again, my name is Kshitij Agarwal. You can find me on Twitter with my handle Funky Idol, and this is a session on Android MVP architecture. So exactly, how is it different from MVC? So MVC is model view controller, and MVP by definition is model view presenter. So what is the difference between MVC and MVP? So before that, we should know what MVC is. MVC is the model view controller pattern that has been employed for many, many years throughout the software industry. It has been actually been there for decades now. And So the pros and cons of the MVC architecture is that the pro is that it provides you responsibility delegation, where model is for the data that you're saving, or the data that you have in your app or an application. View is what the user sees, and controller is what controls the whole flow of the information between the model and the view. Okay, so this does provides a little some amount of responsibility delegation, but the problem with MVC, the old MVC architecture is scalability, modularity, and testability. We'll talk more about it as we move forward, and as we compare this MVC with MVP. So this is a brief diagram of MVC versus MVP. And the biggest difference between MVC and MVP is the portion where model is directly trying to talk to the view in MVC, but it is
How you doing?
not there in MVP. Okay, so MVP is just an evolution of MVC architecture, but the biggest difference is that uh, view is only given any information or the data by the presenter, and by no other portion of the your application interacts with the view. Whereas in MVC, both model and controller could directly interact with the view and update the view uh, of the application. Now, let's directly bring it to the terms of Android. So in the current scenario, how MVC, so Android in itself employs MVC architecture. You have your XMLs for your views, which acts as a view. Your activities acts as the controller as well as the model. So any request, for example, in the traditional Android development, any request that you make through an async task, okay, you make a network request, you in an async task, you retrieve the data, you parse that data, and you do all that stuff inside the activity itself. And then that information is then displayed on the screen. So hence the controller, the activity itself acts as the controller. Okay, and the information is directly taken by the controller. The model is directly taken by the controller and displayed on the view. In MVP, it doesn't happen. How it does happen in MVP is we are going to look at it later on. So, what good is MVP? So, again, the pros of MVP, it gives you separation of concerns. Every layer in MVP has been dedicated to do only a very specific task and nothing else. The responsibility of each layer is very specific, very constrained and confined, so that it does only one thing and it tries to do it the best way possible. Okay, what this leads to is a very modular approach. It becomes very scalable because uh, when it is much easier to add layers and add more components in the MVC architecture, and of course it's become testable. We'll talk about this in the next slide. And the con is that the development speed is definitely reduced a little bit because you have to maintain the whole architecture itself. But the pros itself are cover up for the cons here. So what do we say when we say separation of concerns? So in separation, by separation of concerns, we mean that each MVP layer. Hello. Yeah, I would request everybody to please mute their mics. If you're not able to hear me, then please let me know. You can type it in the chat. Okay, so Let's talk what separations of concerns is. So each layer in MVP is bound by a contract, and we'll talk about contract as we go through the code. The model and view layers actually never communicate with each other directly, as everything, all the interaction between the model layer and the view layer, as you can see here, the model layer and the view layer in MVP can never interact with each other, and that exchange of information can only happen through the presenter. Okay, so the view, the one biggest point here in MVP is that the view layer is completely passive. The activity itself is considered is developed in such a way that it is dumb, in the sense it is not going to do anything, it is not going to handle anything. Any interaction, user interaction, is directly passed on to the presenter for to be handled, and, and whatever information needs to be updated onto the screen will be given to view.
I said, can I borrow it? Give it back. I know, right? I'm gonna put it on, use it, and then bring it back. Put it in the big pouch and put it back into the package.
Hi, can I request everyone to please mute their mics? If there's any,
Who? Oh, 45.
If there's any issue, please let me know.
Set. Yes. Oh my God.
Please mute your mics, everyone. I will request you to do that. All of this is being recorded live, so please mute your mics. Okay, coming back to the slide. So like I was saying, the view layer is completely passive. The activity doesn't really handle anything on its own. All the user interaction is passed on to the presenter, and then presenter applies all the business logic and then gives whatever information needs to be updated on the screen. The presenter tells the activity what it needs to do. Activity itself is not going to do anything as part of the MVP architecture. It is very different from what we are usually in the habit of doing in terms of Android development, because we generally write most of 90% of our code in the activity. But this time, almost 90% of the code is not there in the activity. The activity is just there to handle the screen information and how to show it on the screen, and that's it. So right now, the another thing that we need to take care of is that in MVP architecture, Android APIs are bound to the view layer. We do not bring any of the Android APIs outside of the view layer. The presenter layer and the model layer are completely and pure Java classes. The biggest benefit of doing this is model and presenter layers can be JUnit tested without the need of doing any sort of instrumentation for the Android APIs. So functionality of each layer is bound and limited to perform specific tasks, which makes it easier to find and fix issues. Now, if I know where if I get a bug, then I can actually pinpoint. If it is a view related issue, then I know it is going to be in my activity. If it is a business logic issue, I know it is going to be in my presenter. If it is a data related issue, I know it is going to be in my model layer. So coming on to modularity, in MVP architecture, the package definition is very different from your regular package structure. For example, in MVP, we do not create our packages in terms of one package for activities, one package for this thing. For example, one is for segments, one is for activities, one is for your model layer. We don't do that in MVP. In MVP, one package is for your presenter and the contract and the view layer. Okay, so this is how the packet structure is there, and uh, every screen and the packet structure is made in a way that every screen is uh, has its own package. Okay, and each package will contain the view activity or the fragment, which is the view, the presenter, and the contract. We'll talk about the contract once we go to the code. Okay. Now, with each screen having its own package in business logic, it is very easy to modify or add new features in the minimal collision. So what is happening here is now if in a team, there are 3 developers and they're working on different screens, they can independently work on their own packages without stepping on each other's toes, which makes things very uh, modular and easy for the teams to work with each other without getting into a lot of git clashes. Now, in terms of stability, the model layer in MVP architecture is done in a repository format. And so you basically create your own local repository for your model layer, which performs all the CRUD operations, which is create, uh, read, update, and delete of all your model layer. Uh, okay. And model layer is not bound to either presenter or the view, because model can so that model can be reused at different areas of the information. For example, if you have a model for a student, right, you have information of a student which you have downloaded from the server and it is cached in one location. So now you can use that same user student information either in the user profile screen or in the welcome screen, where you are trying to say welcome so and so, the name of the student. So the information is being used at multiple locations. Okay, so but and it is so that is why it is not bound to any specific layer. Okay, so the crux is that with all the parts of the app are placed under very specific boundaries, modification or updates pose very minimal impact on existing pieces. So if you're changing anything on the model layer, it is not really going to affect the view layer. If you're making any changes on the view layer, it is not going to affect the model layer. Testability. Now, since most of our code is converted to pure Java as part of the model and the presenter classes, it can be easily tested using JUnit. Now, it is much easier to write the tests, and because as the code is broken down into smaller modules, it is easier to test those modules with your small tests. You don't have to write elaborate tests just to test a very small functionality. Okay, and because JUnit tests run on your own machine, it is the overall testing of your applications become very fast compared to what the amount of time it would take to you to run an espresso test or an Android instrumentation test. So this is the link to the code lab. Okay, you don't need to open it right now. I'll share my screen with the code lab, and we'll go through the commit history of the project. Okay, and then we'll see how to develop an MVP application. Okay, so here we are. This is the code lab. Let me quickly get into the distraction-free mode. So this should start. Okay, so this is the commit history of this project. So what we are going to do is we are going to step through all the first is the basic setup, then we'll create the model layer, then we'll create the repo interface, then we create the contract, which is the important aspect of the MVP architecture, and then we'll go ahead and implement the contract into our view layer and the presenter layer. So I have already checked out the this particular commit history of the basic setup. So let's see what the basic setup looks like. So This is my main activity right now. It doesn't have anything. These are my some of the utility classes that I have created. Okay, sorry. Before this, I would like to show you what we are actually going to make so that you have a better idea how this is going to look like. This is a very simple Android application where we are going to click a button and it's going to make a network request, get some data from the server and show it on the screen. So if I click on this button, it just created some random hidden API, which gives you back some random text, some very hipster type of text, YOLO and whatever kids use nowadays. So a very simple application. You click on a button, the action is taken to the presenter layer. It makes a request to the network layer, get some data, show it on the screen. Now let's see how we are going to do this same thing, which you would have traditionally done through async task. Now we are going to do this through our MVP architecture. So quickly, let's see which libraries we are going to use. So we are going to use Picasso. So I actually just copy paste this. So what we're actually going to use here is retrofit for our network calls. Okay, and butter knife for our handling our views. As part of the basic setup, I have some utility classes which are there, which I use in every project. So you can use them. It is open source. You can copy paste it and use it as per your needs. This is the basic custom application that I have created. We are extending the application class. Nothing fancy here. And we haven't actually begun creating the MVP as of yet. So now let's move on to how to create the model layer setup. So we'll quickly check out this revision and see what changes we can see. Now you see there is a new package model and it creates two Pojo classes and one interface. Now this interface is going to be the repository pattern for your model layer. So this interface that you see, this is going to get the hipster text. Okay, so it has a callback. This callbacks gives you, the on success and on failure. This is an interface as well. And this is the retrofit API interface that we have created. If you are aware with retrofit, you will get it very easily. In case you are not aware of retrofit, so basically what we are trying to do here is we are trying to define the API call that we are going to make. Okay. Excuse me, can you please mute your mic, please?
जैसे ही घुसोगे ना अंदर तो राइट साइड में विजय बैंक के मतलब आगे जो वो स्वीट्स के लेबर शॉप पे तो फिर आगे कहीं से भी ले लो यार शर्मा वर्मा वाला होगा या कोई ना कोई तो होगा कहीं से भी ले लो कहीं से भी ले लो.
Okay, so I think let's continue with whatever disturbances we are facing. Okay, so this is the repository pattern that we are trying to create for the model layer. Okay, so this is the Pojo classes that we have. This is basically what the data that this is going to handle the data which we are going to receive. So what retrofit is going to do is it is going to make a call to this API. Okay, the name of the API is here. So this is hipsterjesus.com. This is the name of the API. Making the call to this API, it is going to return a text, JSON, and this JSON will be automatically passed and stored in this model. Okay, pretty simple, nothing fancy. And yeah, so you set this whole thing up, and that's pretty much it. So let's move on to the concrete implementation of a repo interface. So let's quickly see what this is going to look like. And we'll do this actually using this, so that it is easier to actually glance what this is, the changes that we're going to make. Okay, so this is the implementation of the repo interface that we have created. So let's quickly move to this particular revision and okay. So here is the implementation of this repo interface. We had an empty method get hipster text. This uses a callback, get hipster callback. So inside this, we are not doing much. We're creating the retrofit call, trying to make a network call here. And this is going to get this is going to make the call. The callback will receive the response. This is going to receive the parsed object response.body. And if it is not null, then we are going to pass on this object to the callback on success. And if it is a failure, then we are going to throw the exception. Very simple, nothing fancy. So one thing that you have to note here is, instead of starting in implementation of our application from the activity, we are actually starting from the model. So first we need to set up our model and how we are going to fetch our data and everything. And then we will move on to the actual implementation of the application. So please take a note of that. So now we move on to the contract. So let's quickly take a look what this contract is going to look like. So this is a contract, an interface, main contract, and this contract will interface will have two more interfaces, one interface view and one interface presenter. So this view presenter is going to be implemented by our activity, which is going to be the view. Now the interface presenter is going to be implemented by our presenter, which is going to handle the click of the button on the screen. So, well, I know this might sound a little confusing, but let's move forward. And if you still have questions, we'll definitely take it with us. So let's quickly check this out. Okay, have a quick look. And before and as we take a look, notice that model package is independent of the main package, and we are calling this main package because this we just have one activity, main activity. So that is what the name of the package is. Okay, so let's have a look at the contract again. Interface, main contract, interface view, which is going to be implemented by the view, which is the activity. Interface presenter, which is going to be implemented by our presenter, which we'll call main presenter. Okay. Now, again, back to the commit history. Let's look at what we are actually going to do. So here it is. This is the activity, the main activity we already had. What we are going to do here is we are going to, this activity is going to implement the main contract dot view. Okay, which means it has to implement this particular method from the interface, which is update hipster text. Okay, and for our presenter, we created a main presenter, which is going to implement our main contract dot presenter, and this is going to again implement the method which we have defined in the interface. We'll now see what the actual implementation of this is going to look like. Quickly switching to this revision. Okay, again we look at this. The presenter is inside the main package. So like I said in the slides, the contract, the view, and the presenter are part of the same package. So each screen will have its own view, its own contract, and its own presenter, and they are going to be placed inside the package of that particular view. Okay, so we have the presenter, which implements the interface presenter from the contract. We have the activity, which is implementing the view from the main contract. And now we'll see what this is actually going to implement. So let's quickly have a look again at the contract and see what is happening. So now, or rather, let me do this. Let me show you this. This is going to show you how the uh, view and the presenter are going to be connected with each other. See, we are saying that activity is very passive. It is not going to do anything. It is going to delegate everything to the presenter. So it should know everything what it needs the connection to the presenter. And now we'll see how we'll make that connection. So inside the activity, we are adding an object to the presenter. Okay, we'll create this object and we are passing this. This object of the main activity is nothing but a reference to the main contract.view from the main contract interface. Okay, and this is how we are creating the connection. We are giving the object of the activity to the presenter through the constructor of the presenter, and inside this it is going to keep the reference for the view within the presenter so that it can update the view from itself. We'll actually once we write the code, we'll actually see how this is going to work. Okay, so let's quickly move to this revision and let's see how we are actually now we have created the connections. We have seen how the connection is being made inside the activity. We're creating an object for the presenter, and we're giving the current activity object to this presenter through the constructor. Okay, now let's see how to call the presenter from the view. So this is it. We have created the buttons, we have created the text view which is there inside our XML. Okay, and we can see here is on the click of the button, like I said, activity is going to be completely passive. So on the click of this button, what we are doing is we are just telling the presenter, please handle the click of the button. The activity is not going to do anything by itself. It is just taking the on click from the user and telling the presenter, please take care of this presenter, please take care of this action. I don't know what to do about it. And I don't want to do anything about it. And we don't want anything, we don't want the activity to do anything about it, because if we ask the activity to do anything about it, we are going back to the old ways of developing. Oh, so again, we are delegating, or we are delegating the handling of this click of the button to the presenter. We had the presenter object, and we're just saying presenter.onClick hipster button. So this will basically delegate the handling of the click to the presenter. Okay, and we are quickly filling up this method, update hipster text. Okay, this will basically take that string passed from the presenter and set that text which was passed from the presenter into this text view. This text view, TV hipster text. Nothing fancy, simple. It is going to take the string which will be passed from the presenter and giving it and set it to the text view. Again, activity is not going to do anything. For that matter, we are actually finished with our activity code. We are not going to modify the activity more than this. The activity part of the code is already complete. We have just handled how the data which will be sent by the presenter is going to be handled, and we have delegated the task which was initially the activity was supposed to handle by itself are now given to the presenter. Okay, so let's come out of this, and I will, for your reference, quickly show you the contract again so that you'll know what is actually happening. In the view, when we implemented the view interface, there was a method that we created, update hipster text. This means this method was created so that the presenter can update the view by calling this method. Okay, so we'll move to this revision. We'll see now, as the commit history says, presenter logic for handling view action and updation. Now we are actually going to write the complete business logic of the application. And that's it. All we have done is that we have created the model layer, or rather we have called the model layer. We have created a called the hipster repo, use the implementation class of this repository, and then inside the method, the handling of the click button, we are actually going to perform the task. What was the task? Get the information from the server. How we are going to get that information from the server? By calling to the repo. We'll say repo get the hipster text. Okay, we're telling the repo get the text. All we have to do is we have to pass a new callback, an asynchronous call to the repo, where once we receive on success, we say, important, this is very important, we're saying view.update hipster text and give it the data that we have received from the model layer. So what is happening again? View called this method on the click of the button. So view delegated the calling of the clicking of the button to the presenter. Inside the presenter, when this method is called, it is going to, now the presenter is going to call the repo and ask, get me the hipster text. Using an asynchronous call, we have the callback, and inside the success of this callback, we get our response. This is the response. This is the model that we have received from the server, and we are sending that data to the view. We say view.update hipster text. In case of failure, we are just going to show a toast, and I'll try to do that if we have time. We'll quickly try and show a toast inside this MVP architecture. Okay, please, any questions at any point, keep messaging it inside the group chat. We'll definitely take all your questions after this session. Okay, you're most welcome to ask any and all questions that you have. So we have moved to this layer and we're actually done. We can run our code. Our development of this is complete. Okay, so at the end, what you see is this thing. Click of the button delegates the clicking of the action to the presenter. Presenter calls the model layer repository, asks the repositories to send the data back. That data is then sent from the presenter to the view, and the view takes the data and it updates it on the view. Okay, this is the crux of the MVP architecture. Okay, now quickly we'll see. Now you have the architecture ready. You have made this, you have released it. Now, for example, you wanted to say, okay, in case of any failure, I want to show a toast message to the user. How do you modify an existing MVP architecture code? Let's see that. Okay, so first of all, the first change that you are going to do is to the contract. In the contract, we say that the view is going to show a toast and it is going to show a message given to it by, of course, the presenter. So the view is going to show a toast. The activity which was in implementing the view interface is now going to handle the toast message. Okay, it is going to take the string message and show it in a toast. And that is the change that you had to do to the activity. That's it. And for the presenter, the only change is in case of failure, earlier we did nothing, but now what we are doing is we are telling the view to show a toast message. And in that toast message, we are giving it the exceptional, the message through the throwable exception. And that's it. You've made a change to your app with minimal impact on any each of these layers without making any major changes to your whole application. Okay, so if we check this out and look at the final code, this is the final code. This is the contract. A view interface with the hipster text. It is going to update the text on the screen. This is going to show a toast on the screen. It will take the string from the presenter. It is the toast is going to take the string from the presenter. The presenter is going to do one thing, and that is taking the action from the user, from the activity. Okay. What it does when it takes the action from the activity, it makes a call to the repository. It asks for the text, gives it a callback. In the success of this callback, it gets the model. It takes the information from the model, sends it to the view, and tells it to update the text on the view. In case of failure, it is going to tell the view, show a toast, gives this message, show this message on the toast. That's it. Again, on the activity, for updating of the text, just simply text view.set text of the text that we received from this presenter. In case of toast, just make a toast, get the message from the presenter. That's it. The activity is not doing anything else. In case of a click of a button, all it is doing is delegate this click to the presenter. We'll have a look at the data model repository again. This is the interface repo. We had the method to get the text. We were using a callback, which we have defined here itself. It is a success failure model interface. And this interface is purely for the retrofit network call. Okay. So coming back to the slide deck, how you can further evolve MVP architecture. We can create Android Studio Live templates for the for creating these classes very quickly. This will reduce the time of development of this architecture. We can use Dagger for dependency injection. We can use RxJava for an asynchronous connectivity between these layers, and Conductor for handling the views. Okay, now the Q&A part will take the questions from the chat. So let me quickly open the chat, and let me quickly pause the share, and we'll have the look at the questions. Giovanni asks, will this presentation be available as a recording at a later date? Yes, this presentation is available, will be available. This presentation is already there on the speaker deck. I can share a link to the speaker deck later on. Okay, anybody has any questions in understanding? Okay, so the GitHub link is already there in the speaker deck. Let me open it again. This is the link to the GitHub repository, which has the project. Sorry, I need to resume the share. Okay, so this is the link to the GitHub repository. You can go and have a look and experiment it. Sure, Varun. Please go ahead. I have a very basic question, Kshitij. Yeah, please, Varun, go ahead. Please type your questions in the group chat. We have around 10 more minutes, so we have plenty of time to go through any and all questions that you might have. Rebecca Strong, can you talk about the test that you wrote for this demo? Okay, Rebecca, I haven't actually written any tests for this demo. Tests were not actually part of this talk. They were not part of this agenda of this talk. This is not, unfortunately, this talk is just going to be about the MVP architecture. So for tests, probably I'll conduct another officer for writing JUnit tests at some later date. Sorry for that. Okay, Varun. So you have a question. Let's say I'm using activity controller model. So my controller is basically playing the same role as a presenter. Yes and no. So the difference between a controller and a presenter is that right now most of the actions are being handled. So there are multiple differences. Uh, you also asked why would I migrate to MVP? Yeah. So the so the differences that I've already talked here is this. So have a look at this. So in controller, if you in the MVC architecture, the model is directly talking with the view layer. Whenever right now, if you look at your applications which you might have created till date, the moment you make an async task, for example, the data that you receive, you directly show it on the screen right through the activity. Okay, so basically what is happening is activity is taking care of all the pieces of your application, including making the network call to the server, fetching that response, parsing the data, and showing that data on the screen. Everything is being done by the controller itself. Okay, so that is one thing. Secondly, if your app is creating a presenter model, so the MVP of one thing that you have to understand is that what MVP says is that uh, MVP asks you to migrate all of your code from activity to a presenter on a model layer. What? And additionally, in addition to that point is that the Android libraries are not used outside of the activity. So I'll say this again. We are taking out the code outside of our activity and converting it to pure Java classes. Okay. And those Java classes can then be easily be JUnit tested. That was not the possibility inside an MVC architecture. With MVP, you can JUnit your business logic inside your presenter. You can JUnit your model layer, the network call that you are making and doing using JUnit and Mockito. Okay, and with controller, this was slightly more difficult to do that. Okay, so okay, so in continuation to what you asked. So you say, no, my controller is written in the same way. Activity transfers all the actions to the controller, and controller bring data to the activity via DB or network. Flow of action is activity to controller to data or network layer back to the controller to activity or adapter. Yeah, I mean, that is, what you are doing is you're pretty much inching towards MVP architecture. I'm not saying what you're doing is wrong. It is pretty much what MVP is. The name controller or presenter is just for the sake of definition. So what you're actually doing is what you're calling a controller is actually a presenter in terms of an MVP architecture. So it is what you call a controller is actually a presenter. Okay, so any other questions from anybody? I have paused the sharing. If there is anything else, you're most welcome, Varun. If there is anything else anybody would like to know, we still have 5 more minutes. We can cover some questions or any specific thing that you were a little unclear and you want me to repeat, we can do that as well. No problem at all. Okay. Okay. So I don't see any questions coming in. No, it's not a problem, Giovanni. The code will be available. I will post the link to the presentation. Let me quickly do it now. So I'm going to post the link to the presentation is in the group chat. So you guys can this presentation contains one of the slides contains the link to the GitHub repository, so you can very well go there, check out the code, see it, experiment it, and there are a couple of slides which were left in the presentation. Not much, but just some additional resources. You can find that in this slide deck once you have a look. Okay, Shubhendu asked, can you please explain the model part and how will it be independent? Okay, sure. Okay, so let me quickly start my screen share and I'll go through the. Okay, so Shubhendu, like I said, our model layer is going to be on a repository pattern. And when we say repository pattern, which means we create a class which stores the data or caches the data for that matter. And it has methods which will allow the other layers of the application to access the model layer using CRUD methods. By CRUD, we mean create, read, update, delete. Okay, so you can read the data through from the model layer through those methods. So for example, the method that we have created, get hipster text, is actually a read method that we have provided. So this repository is right now providing only one method to receive the text from the actual model. So model is this Java Pojo that we have created. Okay, this is the model. The data will be cached in this model, and this repository is doing nothing but giving you a method to give you the access to this particular model. Okay, and this is the implementation of the internal implementation of what repository implementation is going to do. It is going to make a network call. It is going to get the data, and it is going to cache it, and it is going to return that data through this callback, right? This implementation is completely hidden from the rest of the layers. Okay, so what is going to happen is this information is hidden from all the layers. They don't know what the repository is doing, whether the repository is showing the data from which is already cached, or it is showing the data from the network layer. So handling of the data is being done by the repository, whether it is coming from the cache or from the network. So the presenter doesn't know whether it is coming from network or from a cache. Okay, does that answer your question, Shubhendu? Okay, so while I wait for the Shubhendu's response, Varun asked one more question. Is this the globally accepted way to write MVP using contract? No, Varun. There is no globally accepted way to write MVP. MVP is a paradigm, development paradigm. There are a million ways to implement MVP. For example, if you introduce Dagger, the whole way of using MVP, what we have seen here, is it will completely change. If you introduce RX Java, it will further change the way this MVP is implemented. If you search for MVP related libraries, there are so many libraries which are available on the net on implementing MVP. What this MVP architecture, which I have showcased today, is the most easiest self implemented MVP architecture. We are not going using any external libraries for the MVP itself. Yes, we are using retrofit, but nothing else. But that is just for the sake of the network layer, not the MVP itself. Okay. Okay, everyone, thank you so much. It is 1 hour since we started this session. And thank you, everyone, for your patience and for listening. Any questions? My Twitter handle is @FlunkyIdol. You can contact me on Twitter, and there is a online discussion board which you can find the link in the speaker deck. You can contact me there as well. Thank you so much, everyone, for joining in. See you soon.